Section 4.1 Basic Graphs. In this section, we will sketch the graphs of 6 trigonometric functions, determine the range of the graphs of 6 trigonometric functions, and also use the odd and even function property to assist us while we are graphing them. When we sketch the graph, we look at the unit circle. As you notice, the unit circle with an angle t, the coordinate x, y represents the cosine of t, comma, the sine of t. That means the cosine t, that is the x coordinate, and the sine of t is the y coordinate. When we are sketching the sine graph, we're gonna look at the y coordinates on the unit circle. Oops, wrong one, sorry. Y. So that means if we look at the first quadrant or quadrant 1, for an angle t, 0, the sine of t is 0. For an angle pi over 4, the sine of t is 1 over square root 2. And for pi over 2 angle, the sine of t is 1. And we look at this number and this number and this number. And when we plot them on the graph as the coordinate of the t comma sine of t, the first coordinate 0, 0. Let's use different colors. So this one 0, 0. And then next one, when t is pi over 4, the sine is 1 over square root 2, which is about 0.7. And when pi over 2, the sine of t is 1. As you see, this portion of the graph is from the coordinates from the first quadrant on the unit circle. To summarize, so this one, when you look at the unit circle, at the intercept, this is the coordinate 1, 0, 0, 1, negative 1, comma 0, 0, negative 1. And when you draw the circle, it comes back to the point 0. That means when an angle 0, which is the coterminal of the angle 2 pi, and over here an angle is pi over 2. Right here is an angle pi. On the bottom here, an angle is 3 pi over 2. So we look at 5 key points. What are those 5 key points? When an angle t, 0, pi over 2, pi, 3 pi over 2, and back to 2 pi to finish one cycle. The sine of t is 0, 1, 0, negative 1, and back to 0. So as we go counterclockwise orientation. So at pi over 2, the sine is 1, and at pi, sine is 0, negative 1, and 0. So these are called 5 key points of the sine graph. So when you sketch the graph of the sine of t, so you break it up into 5 key points at 0, at pi over 2, at pi, at 3 pi over 2, at 2 pi. And then as you see, the maximum is at 1, minimum is at negative 1. So scale it as the height of the function, maximum is at 1, the minimum is at negative 1, and then locate the points, the 5 key points on this xy on this plane. So at 0, 0, right here, pi over 2, the function value is 1, down to 0, negative 1, and 0, and then sketch the graph or use the curve to connect all 5 points. So this is a quick way to sketch the graph of y equals sine of t, or y equals sine of an angle theta, or x, depends on what variable provided in the problem. From sketching the sine graph, once we go past x equals 2 pi, we will begin to name angles that are coterminal with the angle between 0 and 2 pi. As we go from 0, finish one cycle at 2 pi, and then go another round. So that means we're going to hit the coterminal of the whole set from angle 0 to 2 pi. The graph of y equals sine x, as you notice, it never goes above 1 or below -1. Repeat itself every 2 pi units on the x-axis and crosses the x-axis of the multiple of pi.